Okay, we are going to start looking at the quadratic section of our review. So we're going to start with a really quick overview of what we looked at back in units 8 and unit 8 and 9 when we talked about quadratics the first time around. And then we're going to start with graphs. Same sort of structure as our linear review. We're going to start with some graphs. So for our quadratic functions, our graphs are this U-shaped thing called a parabola. The one I have on the paper here for you opens up, but they could also open down. That would also be a parabola. When I have a table of values for a parabola, we talked about this in our last unit, we can actually sometimes, but not always, potentially pick out the vertex from our table. So we look for those repeating y values because our parabola is symmetric. We get these repeating y values, and if we follow them to the center, we can find the vertex of our parabola. And the vertex is that sort of middle point on our parabola. Something that we didn't talk about so much in our quadratics unit, but that you will see in Algebra 2 next year, is there is actually a pattern to the y values when I'm looking at a table for a quadratic function. So when we talked about our linear functions, we said that the y values were always increasing or decreasing by the same amount. So I was always adding 2 or subtracting 5. If I look at my y values here for my quadratic function, to get from 4 to 1, I would subtract 3. From 1 to 0, I subtract 1. 0 to 1, we add 1. 1 to 4, we add 3. So I'm not doing the same thing each time here. However, there is still a pattern. And this is something that we'll use and work with more in Algebra 2. But if I look at these numbers now, to get from -3 to -1, I would add 2. To get from -1 to +1, we add 2. To get from +1 to +3, we add 2. So there is still a pattern here, and we'll work with that more in Algebra 2, and that idea will come in handy for some of the later stuff we'll do in our review unit. We have 3 different function forms for quadratic functions: standard form, vertex form, and intercept or factored form. They each tell me something unique about my quadratic function, about my parabola. The standard form C value here at the end, that constant term, tells me my y-intercept. And then the A value in front here, I want you to notice we see as a lead coefficient in each of our forms. That A value tells me the shape of my graph. Which way does it open? How do I get from the vertex to my next point? We'll talk about that in just a minute. Vertex form tells me the vertex. Notice that this is a similar format to point slope form from our lines. In point slope form, this would have been the slope, and then we didn't have a square here, but a really similar setup to point slope form. In point slope form, these two values came together to create an ordered pair representing a point that was on my line. The same thing is true for vertex form. H and K together represent a point on my parabola, specifically the vertex. The vertex form tells me the vertex. Again, I get the shape of my graph from that A value. And then for intercept or factored form, M and N, whatever they are, tell me x-intercepts for my graph. Most, not quite all of the applications that we saw for quadratic functions were some type of projectile. So we were throwing something, we hit a golf ball, we tossed a wiffle ball, we maybe launched a rocket or a firework or something. In most cases, for those applications, for those modeling problems for quadratics, we were looking at something that was going up into the air and coming back down. Okay, some kind of projectile. There are other things that we can model with quadratic functions, and we'll see some of those things that are not projectiles. We'll see a lot of projectiles too, but we'll see some things that are not projectiles. There are a handful of situations we can model with a quadratic where we actually start high, go low, and then end high. but the vast majority of the ones that you can expect to see and that we have already seen in Algebra 1 and that you will see in Algebra 2 are going to be some sort of projectile where I go up and come back down. For today, our focus is going to be on graphing from vertex form. So we'll look at graphing functions in standard form and graphing functions in factored form a little later on. We're going to start with vertex form. So I know we just talked about this above, but vertex form of a quadratic tells us the vertex of our parabola. Okay, remember that's this point right here, that sort of center of my parabola. It looks like y equals a times x minus h squared plus k, where h comma k is our vertex. Just like with point slope form, whatever sign I see here for h, it will be the opposite when I actually give that point, when I give those coordinates. And then again, the a value, that lead coefficient, tells us the shape of our graph. When our a value is positive, our parabola opens up. When our a value is negative, our parabola opens down. So the sign tells me which way my parabola will open, and then the actual value gives me some other information. So ignoring the sign, if my a value is greater than 1, our parabola is going to be super skinny, sort of stretched out, and that's what we called it way back in Unit 8. We said that our parabola was stretched. If our a value is less than 1, again, ignoring the sign there, then our parabola will be sort of smashed down, kind of widened, or we call this a compression. So we're going to take a look at graphing some functions from vertex form. Then we'll reverse and given the graph, write some functions in vertex form. But we're going to start with our graphs. Now, just like when I was graphing my lines, I started with the points and then used the direction for my equation. In the case of a line, that means slope, but I used the direction for my equation to get some more points. Here, we're going to start the same way. We're going to start by identifying a point. Since we have vertex form, that point that we identify is going to be the vertex. So for A, my vertex would be 1, 2. Remember, opposite sign from what's in parentheses with x. So 1, 2 is my vertex. I'm going to plot that point, 1, 2. And then I look at the a, the lead coefficient, to determine the shape of my graph. So if I look, I don't see a number in front here. Okay, I don't see anything in this spot. That means that we just have 1. So 1 is the default. That means we'll have the same shape as the parent graph. So we're going to open up, and from my vertex, my first set of nice points to graph would be out 1 and up 1 on either side. And then my next set of nice points, because I always have to plot 5, my next set of nice points, counting from the vertex, would be out 2 and up 1, 2, 3, 4. Once I've plotted my points, I'm going to connect them for my arrows on the end. A parabola should always have this U shape. It might be upside down, it might be really tall and skinny, it might be very wide, but it should always have that U shape. For B, same idea. I want to start with my vertex. So my vertex here would be -3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Plot our point. And then we look at that lead coefficient to determine the shape of our graph. Since this number is negative, our parabola is going to be upside down. It's going to open down. Since I've got a 2, it's going to be stretched. And remember that stretch, really my lead coefficient in general, we could say impacts the vertical distances. How that vertical change from the vertex to the next point happens. So since it's negative, instead of going up, we're going down. And then the 2, again, means a stretch. So normally I would go out 1 and down 1, but that 2 tells me I have to double the vertical distance. So instead of 1, I have to double it to 2. And I do the same thing on both sides because parabolas are symmetric. For my next set of nice points, we count from the vertex always, out 2, and then normally I would go down 4, but we've got to double that to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then same thing on the other side, out 2, 1, 2, 3, 4, 5, 6, 7, 8. And then don't forget to connect your points and sketch in your parabola. Questions for me so far? Okay, let's turn the page and look at a couple more. So on the next page, for C, we've got another vertex form function here. My vertex, I always want to start by identifying a point on the graph. My vertex would be -2, -4. So -2, 1, 2, 3, 4. And then our A value this time is a half. So we're going to have a compression this time. It's going to be kind of smashed down or wider than normal. So what we're going to do is take our vertical distances and cut them in half. We still go out the same amount, but the amount I go up is going to be changed. So out 1, normally I go up 1, but we're cutting that in half. So I'm only going to go up a half. And then out 2, normally we go up 4, but we have to cut that in half. So we only go up 2. And again, same thing on both sides because parabolas are symmetric. For D, I don't see an H or a K value. There's nothing in with X and nothing at the end. What does that mean for my vertex? It's what? Sorry. It's at the origin. Yeah, it's 0, 0. The only numbers I could be adding or subtracting and not have to write would be 0. Okay, so that means my H value is 0, so is my K, and our vertex is at the origin. For my lead coefficient, I just see a negative sign here. That means -1. So I'm going to be flipped, but not stretched or compressed any. So out 1, down 1 on either side, and then out 2, down 1, 2, 3, 4. And same thing on the other side. 2, 3, 4. Not too bad? Does it seem familiar? Yeah, we've done this a whole bunch of times. Okay, so with a function, we can create the graph. Now we're going to go the other way. With the graph, we're going to create the function. We're going to do this in the same order though. I'm going to start by identifying the vertex and then look at the shape to determine my A value. Okay. So my vertex for 2A is at -3, -2. So I know if I plot this into vertex form, I would have x plus 3 squared minus 2. Remember, what I see in parentheses with x is the opposite sign from the point on my graph. And then I need to look at the shape of my graph to determine what that lead coefficient should be. So from the vertex to the next nice point, I go out 1 and up 1, and I do the same thing on both sides. For my next set of nice points, from the vertex, I go out 2 and up 1, 2, 3, 4. Out 2, up 1, 2, 3, 4. That's the shape I expect. That's the same shape as my parent graph. That means my lead coefficient is just 1. If you want to write a 1 in there, great. If not, remember 1, we don't have to write for that lead coefficient, but don't forget your y equals in front. Number 2B, same idea. I'm going to start with my vertex, and my vertex on this one is at the origin, 0, 0. So there are 2 ways I could write this, and I would take either. I could say that I have x minus 0 squared plus 0. Or you could say, well, x minus 0 is just x, so that's really just x squared. And then adding on 0 doesn't change it, so it's still just x squared. So I would take either version here. And then I need to look at my lead coefficient, what should that A value be? So from my vertex to the next nice point, I go out 1 and up 1, out 2, up 1, 2, 3, 4. Again, that's the shape that we expect. So my lead coefficient here would be 1, which you can write or not. So B is actually our parent graph, right? That's our most basic quadratic function, y equals x squared. This is as simple as it gets. Questions for me so far? No, for the 0, if you want +0 there instead, that's absolutely fine because 0 doesn't have a sign. So, and if I wanted to, I could even make this minus at the end because again, 0 doesn't have a sign. Okay, let's take a look at C. Again, I'm starting at the vertex. So my vertex here is -2, comma, -3. So if I throw this into vertex form, I would have x plus 2 squared minus 3. And then I need to see what that A value will be. So from the vertex, I go, well, I want to go out 1 and up 1, but there's not a point here. It's here. Let's try out 2. If I go out 2, up 2 gets me the next nice point. Now, normally it's up 4. Since I only went half the distance, that tells me my lead coefficient would be a half. That makes sense? You try D. What's your vertex? 7, 1. So this would look like x minus 7 squared plus 1. What's your lead coefficient going to be? -1. Yeah, we go out 1, down 1. Out 2, down 1, 2, 3, 4. So the shape is maintained. It's just flipped upside down. So we would have a negative lead coefficient here. Just the negative sign is fine, or -1 if you'd rather. Questions for me? Okay, there's one more thing that we're going to take a look at for today with our vertex form. I want to do a little practice identifying some features of my graph without actually graphing it. Okay. Now, I asked you, particularly for A, B, C, and D, I asked you these questions as we were graphing. So here's the function, what's the vertex? We figured that from the function. Is this going to open up or down? We figured that from the function and then use that information to create our graph. In Algebra 2, we're going to want to be able to answer some questions like this. What's the vertex, or what's this key feature? And then what's the shape of my graph? We're going to want to be able to answer some of those questions without having to always rely on the graph as sort of a backup. So that's what we're going to practice here on page 13. So if I take a look at A, what's the vertex for this function? What's the vertex for A? -2, -4, very good. And will this open up or down? Up. My lead coefficient is positive, so this opens up. How about B? What's my vertex? Very good. I don't see anything at the end here, so that means that it's 0. So our vertex is at 5, 0. Which way does it open? This opens down. Our lead coefficient, our A value is negative, so this opens down. How about C? Vertex is at 317, and this opens down. For D, good, our vertex is at 0, 3, and this will open up. Now the last couple here, E and F, we've got tables. We talked about how to identify the vertex from the table, so let's start there, okay? For E, to find my vertex, I'm gonna look for those repeat Y values. So I've got some repeat Y's here, and I'm gonna follow them to the middle. The middle of those repeating Y's is my vertex. So my vertex would be the point 2, 4. Now, the tricky part here is deciding which way this opens. If I have a graph, I can look at the parabola and see, is it opening up or is it opening down? If I have a function, then I have that lead coefficient, that a value, to see if it's positive or negative. In a table, I don't have that information. I just have a list of the points. So what we're going to do here is look at the vertex and then look at the y values on the either side. Okay, so I know this says don't graph it, but I do want to sketch us a little picture so we can see what we're looking at, or sort of have a visual to match what we're talking about. So my vertex has a y value of 4. I don't care about the x right now. I just care about the y. 1, 2, 3, 4. Put it right there. On either side, my y values are 5. So that's up here and up here. Since the y values on either side are bigger, that means my vertex is the bottom, right? It's going to be the bottom of my graph. My y values on either side are going to be bigger, so that vertex has to be the bottom. That means that this has to open up. If the vertex is the bottom, that means my parabola has to open up. Does that make sense? And it's a little tricky, but we can do it. For F, where's my vertex? Yeah, right here. Look for those repeat y's. Follow them to the middle. There's our vertex. So our vertex is the 0.9, 0. And now if I think about where the vertex would go, it goes where the y is 0. And then the y values on either side are less than 0. So which way will this open? Down, yeah. It would have to be shaped like this. The vertex is the biggest y value, so everything else is down. Good work. Questions for me for today? Okay, we've done this a whole bunch, graph from vertex form. We'll look at graphing from factor form and graphing from standard form in our next couple of lessons.